This video lecture is a walkthrough of Heat Exercise Part 2 for GPH 301 Intro to Quantitative Methods in Geography. Previously we looked at calculating mortality rates from heat, but certainly death is not the only outcome from heat exposure. Morbidity or illness is probably a more common outcome from exposure to excessive heat. And there are a variety of types of illnesses that can result from excessive heat. Many of these actually are related to pre-existing medical conditions. So if people have existing respiratory or cardiovascular or cerebral problems, the excessive heat can actually make them worse, that they can become acute and people can end up in the hospital. And that's the data we're going to be looking at here. So we're starting with the same workbook that we used last time to look at mortality. This time we're looking at the ED visits worksheet or tab in that same workbook. And this data that we have here, it comes from Centers for Disease Control tracking program looking at heat-related illness between 2005 and 2010. It also comes from a research article that was published showing that analysis. So what we have here is the numbers of people who were tracked over that time period, and these are broken up into different groups. We have both their populations over that time period, and then we also have the number of people from those groups that ended up in the emergency department because of heat stress or heat-related illness. So, for example, this number right here, 98,000. So 98,000 people over that time period ended up in the emergency department as a result of heat-related illness. This is broken down by sex, by different age groups, by year, by month, and then by climate region and urbanicity. So we have a little bit of geography there. So the climate region, you can see in the PDF document for this assignment, has a map that shows you the different climate regions so you can understand where those people are coming from. So, and what that means is that when we look at these numbers, we're saying that, for example, 1,200 people from the southwest part of the U.S. ended up in the emergency department. Excuse me. And then urbanicity refers to the size of the city or how developed it is. So a large central metropolitan area is like New York or Los Angeles, and a non-metropolitan area is something that's going to be rural, for example. So we have then the numbers of people from those different categories, groups that ended up in the emergency department. And what we want to understand is the risk to these different groups, to understand, are there big differences between these groups in terms of the chances they might get sick as a result of exposure to heat? Or another way of thinking about it is, are some of these groups more or less vulnerable to this particular hazard? So there's a variety of ways of looking at that. We have the absolute numbers. So for example, we can see that nearly twice as many males as females ended up in the emergency department because of heat-related illness. But the question we want to know is that a lot more than we would expect, right? And that's constantly, recall that we're constantly referring back to that expect, and that's because we're looking for some kind of standard to make a judgment on. The easiest way would be to look at the percentages or proportions of these numbers to get a sense of whether or not they're high relative to the underlying population. So the simplest way is to calculate percentages. So let's do that in the first column. So percentages of heat stress illness, I'll say ED for emergency department visits. And so what that means is that we're looking at what these numbers represent as a proportion of the total population who end up in the emergency department. So just to start off, to make it clean, we'll say, this is the emergency department visit numbers divided by the population of emergency department visits. So if we just divide by that, right, that's 1, which means 100%. That's not surprising. Let's turn that into a percentage though. So this number represents 100% of all of the emergency department visits in the population that we've got here. So what this means is that this number, right, this represents 100% of all of the emergency department visits. What we want to know is, what do these represent? So we're going to use the same underlying denominator, so that means we want to hold it stable. So that means we put $ signs in front of the denominator. We can do that manually by just typing them in, or if you want to be quick about it, you can use the F4 function key on your keyboard and it automatically drops in those $signs for you. And again, that's just to hold the denominator stable, since the underlying population of people who ended up in the emergency department, that doesn't change. So what we can do then is we can copy this formula and we can paste it into the other cells, right? And now we can see real quickly that males represented 67%, so more than half of those who ended up in the emergency department, right? And we can do the same for the other cells. We can paste in those formulas to get a quick sense of where everybody falls there. Now the thing about the percentages that we have to keep in mind or be careful about is that they do represent the proportions or the relative proportions, relative numbers of people from the different groups who ended up in the emergency department. But they don't necessarily tell us whether one group is more at risk than another. For that, we really want to turn to crude incidence rates, because that one will adjust for population sizes. So even though percentages allow us to control for that, right, because all of these are compared to the population of people who ended up in the emergency department, it's not really clear, for example, comparing the different age groups or the different years or the climate regions, whether this is high or whether this means that this is more important than this. In terms of what I'm saying there, is it more important that you're from a particular climate region than you're from a particular sex? Like, which one's a bigger determinant of your risk, right? That's what we're trying to get at, because they're all different, right? It does matter whether you're male or female, as we're going to find out. But the question is, if I was trying to rank the things to pay attention to, do I pay more attention to the sex of the person in terms of their risk, or to their age, or to their climate region, or whether they're in the city or not? And that's where the percentages can't tell us that. And so that's why we opt instead for rates. So we're going to put a second column over here. We're going to calculate the crude incidence rates. So this is just like the crude mortality rates. So we're just using morbidity rather than mortality. I'm going to wrap this title here, though, because it's a little crowded. There we go. So here we're going to do crude incidence rate. Now, previously we were looking at per million, but these numbers aren't quite as large as we were dealing with before. So we'll do these per 100,000. Okay, but the process is the same. We're just picking a different or smaller number. I'll wrap that one as well. Okay, so what that means, the way this works is just like we did with mortality. We are going to take the number of people who were affected, right, death or illness, and then we divide it by the underlying population from which they come, assuming that everybody in that population is equally at risk, potentially, of being ill. So when we do that, to turn it into a rate, we multiply that number by the denominator that we're using. So in this case, we're going to be using 100,000. I could type that out, but it's easier to just put in 10 to the 5th power. And that way I don't make the mistake of accidentally leaving out a 0. So when I do that, we see that the overall incidence rate for emergency department visits, right, is 32.2 per 100,000. So we'd expect in a population of 100,000 that at least 32 or so people would end up in the emergency department due to heat stress illness or heat-related illness. So we do the same thing for the other populations, but here, rather than using the total population, we have to use the population out of which that group comes. So what that means is, if we want to know the crude incidence rate for males, right, the rate that they end up in the emergency department, we have to take their population, right? We don't take the total population because not everybody's a male. So when we calculate this number, we're taking the number of people, the number of males who ended up in the emergency department, and we're dividing it by the number of males in the population, right? Because you can't, again, be a male in the emergency department unless you're a male. But again, if we multiply by 10 to the 5th power to convert it into a rate. Right? So we can see that males have a crude incidence rate of 43.6 per 100,000. And since we've already done this, we can just copy this formula down, right? We can see what the number, how it varies by group. So right off the bat, we can see this pretty dramatic difference between males and females, right? Males have a much higher crude incidence rate, and so we could say they have a higher risk of ending up in the emergency department, right? It's not just that there's more of them there, it actually has a higher risk. So we're going to take the rest of these and copy these formulas down to the remaining groups. And what we should be paying attention to is how these compare. Because now these numbers, the nice thing about them is, since they're all relative to population of 100,000, we can look at these numbers individually and amongst the groups, and we can say which of these has a higher risk. And those things are directly comparable. So we can see that males clearly have a higher incidence rate than females. When we look at age groups, interestingly, we can see that the 15 to 34 age group has a higher incidence rate than any other age group, which is interesting too, right? Because we kind of previously expected that older people would, but it turns out this group does, right? And that should, give us pause. We should ask questions about how that is or why that is. And again, we're veering away or shying away from trying to come up with biological or physiological reasons for these differences, and we're asking questions more often than not about socioeconomic differences between these groups, or social, cultural, or political differences that usually determine these differences. Pay attention to the other groups too. I think the ones that we want to look at also are things like climate region and urbanicity, and we take the magnitude of the size of these numbers seriously. So when we're trying to say, where do you find the highest numbers, right, amongst these groups, that's important. So we can see some pretty big differences between those, and that tells us right away that there are differences in the incidence, and that implies that there are differences in risk. Now, a more direct way of comparing the differences between groups is to calculate the relative risk, right? And we did that previously with mortality, and that's pretty simple because we're just dividing one number by another. But I'm going to show you two kinds of relative risk. So the first one is what we'll call an intra-group relative risk. And intra-group, let me widen that just a bit, refers to inside of a group, intra versus inter, right? And so intra-group means that we're comparing within a particular category. So in that case, we're comparing, let's say, males and females only. And so what I want to know is, how do males and females compare in terms of their risk? So when we do that, we have to decide on who is going to be sort of the point of comparison. And that group is going to be the denominator in the equation. And the numerator is what we like to think of as the target group of interest, the one we're kind of asking the question about. So what does that look like in terms of the sex? So let's say that females are the target group of interest, right? And so what that means is that the female incidence rate is the numerator in the calculation, and then we divide them by the males, the point of comparison, right? And so when we do that, the number that we get tells us how the females compare to the males. And so here we have a number that's less than 1, right? This is new. Previously we were looking at numbers that were bigger than 1 for the most part. So when you have a number that's less than 1, that means that group's risk is less than the comparison group, right? In this case, it's 0.48, so it's about half. So females have about half the risk that males do. Now, when we're doing this, we have to keep the denominator stable. So that means that this should be the same. So I can add the dollar signs in front of it too, right? And what that does is it allows me to then copy the formula to the next one. So this one makes sense because we're using the same group. We're looking at in this case, males compared to males, which sounds funny, but it's going to make more sense when we have more categories within a group. So we can see right here then that females have half, 0.48, the risk of males, and of course males have the same risk as males. Now let's do the same thing over here. So if we look at age, we need to pick the benchmark, the group of comparison. So let's use the 15 to 34 age group as the point of comparison, right? So what that means is we begin by taking their incidence rate and we divide it by that group, right? Now here it's going to be 1 because it's the same group, but we're going to use this to copy the formula. So again, I'll put the dollar signs to keep it stable, to keep the denominator stable, right? Just hit enter. And then I'm going to copy this formula to the neighboring groups, right? And so now we can compare the groups. Let's reduce the number of decimal places though, because it's there's a lot of numbers to look at. So let's make it 2 decimal places. That's easier to read. So when we look at it that way, we can see what's apparent otherwise here is that the other groups have less risk, right? Those numbers are below 1, right? So we can say that, for example, people 65 years and older have 90% of the risk of 15 to 34-year-olds of ending up in the emergency department for this cause, right? So they're not quite the same as, or a little lower than. And then 0 to 4 years, they have about a quarter the risk of 15 to 34-year-olds. So that's really interesting, but it's also, again, a quick way of assigning the differences in risk. So I'll let you do the other one so you can look at those to see how they are, but that's how we interpret them. Now, the last comparison we'll do is the intergroup relative risk. So now this is different. Now what we're doing is we're doing kind of what we did previously with mortality. Now we're going to compare how that risk for that group varies compared to the overall population. This is easier to calculate in a lot of ways because what we're doing is we're again taking the incidence rate, but we're dividing it by the total population incidence rate, right? And we're going to use that constantly. So in here, we're going to stabilize or hold still the denominator. Oops, wrong button. There we go. Hold that denominator constant because it's always the same population or incidence rate that we're comparing it to. So we can see that in this one, and again, I'll lower the number of decimal places to 2. There we go. So males have 1.3 times the risk of the general population when it comes to the chances or the risk of ending up in the emergency department. And we can now copy that formula down because it's already the denominator is stabilized. Females have 0.6 of the general population's risk, right? So notice this is higher than what it was compared to males. So there's a bigger contrast between males and females. And when we look at the general population, there's still less risk for females, and but it's not quite as big a difference as it was between males. We can take that formula and again copy down to the age groups. Oops, hello. And we'll paste. There we go. And so here this is interesting. So previously we saw that 15 to 34-year-olds have higher risk than the other age groups, right? Amongst the age groups, they have the highest. But when we look at the general population, we see something that looks more familiar. So 15 to 34-year-olds are at a higher risk than the general population for ending up in the emergency department, but so are 35 to 64-year-olds, and so are people who are 65 and older. And this is an interesting one because we expected this previously. So it isn't that people who are older aren't at a higher risk. They are. It just happens that they're not quite at a higher risk than those who are in the 15 to 34-year-old age range, which is, an interesting thing. And I might challenge you to think about some of the reasons why that might be. What might be bringing that age group into a situation where they're more at risk of getting sick and ending up in the emergency department. Okay, so you see how to calculate both the intergroup relative risk and the intergroup relative risk. So I'm going to leave that to you to do the remainder of these different categories so that you can compare them. So I'm going to stop here and we'll continue with the last bit of part 2 exercise in the next video.